Good afternoon. My viewers, how are you doing? I trust you are doing great. And here we go. We are here with another episode of our physics. But now we want to talk about motion. Yeah, motion. Our topic for today is motion. And under this motion, we want to discuss some little details about motions. First of all, what's motion? Motion is a change in position of an object moved with respect to time. And we have different types of motion. We have the oscillatory motion, the translational motion, the random motion, and the rotational motion. Oscillatory motion is the motion of an object when the body is vibrating about a fixed point. Example, your phone is vibrating. When it's vibrating, it's emitting a kind of a motion called oscillatory motion. Then the engine of your vehicle, with which the frequency with which the engine is vibrating equals the same vibration of the vehicle, is exhibiting what we call oscillatory motion. Then we have this what we call the rotational motion. Rotational motion is the motion of an object rotating from a fixed point. The example is your circular fan, then the rotating wheel of your vehicle. Even the stereo of the vehicle you are rotating is exhibiting a rotational motion. Then we also have the random motion. Random motion is the motion of an object in a zigzag manner, in an haphazard manner. It's not straight, it's moving in an irregular pattern. An example is the motion of the butterfly. When the butterfly is flying, you can't see the butterfly flying straight. It moves in a zigzag manner, left, right, it's never straight. Then we talk about gas. A gas particle does not move in a straight pattern. For example, the smoke from a firewood, those in Nigeria using firewood, as the smoke is going, it's ascending upward, it doesn't go straight. Then last one is the translational motion. Translational motion is the motion of an object from one point to another. It's moving from point A to point B. Let's assume I'm a runner and I kick a ball. The ball hits the wall and goes back. It's moving from one point to another. It's a translational motion. Then the last one, we have the relative motion. We can see add this type of motion, relative motion, of which we observe and experience it on a daily basis. Relative motion is a motion between two objects in which one of the motion of an object is relative to the other. An example is when someone is on a vehicle and another vehicle overtakes that vehicle. Both of them are exhibiting a relative motion, but both of them are moving, but there is one that is moving ahead of the other. So the motion of this one is relative to the other. Or let's assume a tree standing beside the road, and you are driving and you are looking at that tree. At the point you saw the tree, at the point you start seeing the tree is moving backward. So the movement of the vehicle you are sitting or driving is relative to that of the tree. So both of you are moving in the relative motion. That's relative motion. And then I'm going to talk about time series emotions. We have the speed. Speed is distance over time. We discussed this in our previous video. And please, if this is your first time of watching our video, please allow you to subscribe, click like, and share with your friends. Place some comments in the comment box. Speed is distance over time. We have velocity. Velocity is displacement, which is also distance. Displacement over time. We have acceleration. Acceleration is rate of change of velocity. We have change in velocity over time, which is final velocity v minus initial velocity u over what time. So the unit of this speed is what meter per second. The unit of displacement is meter per second as well. While the unit of velocity is meter per second square. What is the difference between the speed and velocity? Speed is a scalar quantity, velocity is a vector quantity. Speed has no direction, it's distance has no direction. Displacement has no direction. So meter per second, but they both are same units. Why that of the acceleration is meter per second square. So we want to prove the four equations of motion. Four equations of motion are three equations of motion, which are we start from acceleration. A represents acceleration, which is what? Initial final velocity minus initial velocity all over time. So at the end of the day, we have, let's cross multiply. By the time we cross multiply, this goes and multiply this over 1, which probably becomes A T is equal to V minus U. Then, what is V now? Let's make V the solution of formula. So, A T, then this minus U goes to this other side because plus U is equal to V. So, V is equal to, we can do this way, U plus A T, equation 1. That's equation 1. Is equal to V plus U over 2. V plus U, that is initial velocity plus the final velocity plus the initial velocity all over time. That is average velocity. Now that we are having the average velocity, so our displacement now. Yeah, the average velocity is displacement. Now remember that we have total sum of the average velocity is the total sum of the velocity divided by 2. The average velocity can also be the displacement over time. Yes. But now let's assume we want to have the total sum of the velocity now divided by 2 now. What is the value for V? Note that V is equal to U plus AT. So whenever we see V, let's put what? U plus AV. So then we have U plus AT. That velocity can also what? Displacement over time. Yeah. So now we are having the displacement now. So let's displacement, which is something as distance through the specified direction, or we can put distance over time because it's having the specified direction for this time. So now we can now say let distance equal to x. Now remember that this time. So now let's substitute it for average velocity. So it's going to be what? Distance, which is x, or let me represent this by x over t. So now let's substitute delta v with what? X over t. So let's substitute to this equation. Now it's going to be x over t is equal to what? 2u plus 8t all over 2. So we are going to cross multiply. Cross multiply now is going to be what? 2x is equal to 2u plus 8t. Are you getting it? Yeah. Into bracket what? T. So 2x is equal to 2ut plus 8t squared. So let's make x the square of formula now. Having x is equal to 2ut over 2 plus 8t squared over 2. So 2 we cancel 2, then we have x is equal to ut plus 1 over 2 at squared. So that gives us our equation 2. Yeah, that gives us our equation 2. So now we are going to prove the equation, the third equation of motion, which is what? We are going to come back to equation 1. From equation 1, we are going to use equation 1 and equation 2. Remember, equation 1 says, equation 1 is V is equal to U plus AT. V is equal to U plus A. So let's square both sides. Square both sides. So when we square both sides, and because V square is equal to U plus AT all square. So to be V square is equal to U plus AT into bracket U plus AT. So at the end of the day, we are going to have U times U is going to be what? Sorry, I want to use this side of the word. U square is equal to U square plus UAT plus UAT to give us what? 2 UAT. So we are going to have 2 UAT plus AT squared. So now at this point in time now, we are going to factorize this aspect. So V squared is equal to U squared. So let's separate it because they are having a special value. So plus 2 UAT plus AT squared. So now something is common in these two parameters. V square is equal to U square plus 2 is common. Let's factorize 2 out and let's factorize this A out. So I'm going to have 2A into bracket. So it's going to be 2U over 2A plus 8t squared over 2. Yes. So now what happens? By the time we factorize these two out now, remember these two will cancel these two, A will cancel A, then there's something to cancel here, so we're going to have B squared is equal to U squared plus 2A into bracket UT plus, not to cancel here, 1 over 2 8t squared. So for now, let's come back to our equation 2. From equation 2 now, equation 2 says x equal to what? Ut plus 1 over 2at squared. So that means we can substitute this ut for what? For x. So ut plus 1 over 2at squared. Let's replace it with what? X. So therefore, substitute it to the equation, then substitute. So by that substitute, we replace this ut plus 1 over 2at squared with what? X. So we have b squared is equal to u squared plus what? Remember we have 2a, then this one is replaced with what? X. So this gives us our equation 3 now. So we have b squared is equal to u squared plus 2ax, equation 3. So let me summarize it. The whole equation. Equation 1 is what? B is equal to u plus at. Equation 2 is what? X is equal to ut plus 1 over 2at squared. Then equation 3 is what? Which is b squared is equal to u squared plus 2ax. So this is equation 1, this equation 2, this equation 3. So you have to understand basic equations of motion. But I would like you to note one thing. When a vehicle is starting from rest, the initial velocity is 0. Yes, when the vehicle is starting from rest, u is equal to 0. When the vehicle has gotten to its final stage or has come to rest, when the vehicle has come to rest or has stopped, the final velocity is 0. Because the vehicle was moving before then, it has come to rest, and the final velocity is 0. Then, when the velocity of a motion or a body on a motion is constant, that is, the velocity is not increasing, the velocity is not decreasing, the acceleration is equal to 0. Are you getting it? This acceleration, there's what we call deceleration and there's what we call acceleration. Acceleration is the rate of change of velocity, and when the velocity of the body is changing. But when the velocity of the body is decreasing, yes, when the velocity is decreasing in time, the body is set to what? Or the object is set to what? Decelerating. So that aspect, the acceleration is negative. So the acceleration can be positive if the change in velocity is increasing, and acceleration can be negative, which is called deceleration, if the change of velocity is negative. Thank you very much. These are the proof for the equation of motions. We are going to use this to solve other questions. Please stay tuned. Click on that subscription button, like, comment, please share with your friends and let us know. Thank you very much. Love you and have a wonderful day. Bye.